Hello, my name is Nigel Griffiths. I work in IBM Advanced Technology Support in Europe. This is a video about the first look at the new machine. It came out in September 2016. It's called a IBM POWER8. The Hollywood name is S821LC. Now, we're getting some confusion about these Hollywood names. For example, there's 4 machines that are called S822LC from 2 different manufacturers, completely different machines. So we now have to include the machine type model number, which is 8001-12C. The unique thing about this machine is it's a 19-inch rack, which is not unusual, but it's the first POWER8 machine that fits in 1U. That's a sort of inch and a bit, isn't it, in a rack. All the other machines are at least 2U. Now, I'm not meant to tell you this next fact. This machine is actually an OEM from Supermicro, and internally it's known as a Stratton machine. There's a 2U version of this. It's called an S822LC, or one of the 4 machines with that name. That is the same machine, but in a larger chassis, and we call that a Briggs machine. Supermicro is one of the OpenPOWER Foundation companies, and of course it runs just Linux, so there's no HMCs and there's no Power VM hypervisor. There is KVM, of course. Now, Supermicro are a well-known Intel machine manufacturer, and they've taken their Ultra server and changed it. They've changed the motherboard and the processor, the POWER8 processor, of course. That has to be changed, but we've actually picked up a lot of things from the Ultra server range. So we've inherited a very nice chassis, and we've looked at the quality of it. We're quite impressed. It also has the power supplies. The disk bays, we think, are the same as the Intel machines, and we have things like the number of disks that are supported and a high number of adapters are supported, and some of the daughter boards that plug into the back to give us, for example, Ethernet, all come over from the Ultra range. The 2U Briggs machine, of course, allows some more disks to go in here, larger fans for the cooling, so the processors can run at a higher gigahertz rating, and of course there's more PCI slots, and they can fit in 2 of the NVIDIA K80 GPUs. Next, we'll do a quick flyby, a live video looking around the machine and taking the lid off so you can have a look inside. Then we'll look at some static images of the details of the guts, and I'll go through some of the configuration options we have inside the machine. So here's the machine on our computer room table. Here we can see the on-off switch in the status LEDs. There's 4 displays with a new IBM logo. On the left here we have a pull-out tab with the machine type model number and the serial number large enough so you can actually read it. Next we'll pull out one of the discs, we'll release the tab, pull around the handle and pull it out. It's nice, a snug fit, it works very well. And that's the CAPI coming out, we have the disc inside, and this is the SATA connector at the back. Next we have a look at the back of the machine. On the right hand side there's 3 PCIe slots, empty in this case. Then we have connectors to the service processor, 4 Ethernet connectors there, and then we have 2 power supplies. We'll just pull one out, release the button and give it a nice pull, and there we are. To remove the lid and get inside the machine, we have to remove it from the rack. On the table here, 2 little screws that we need to undo. I've done one, this is the second one. My colleague is then going to press on these 2 buttons and we nudge the top backwards and we can lift it off, exposing all the interesting stuff. Now we'll have a quick look around inside. My colleague is going to take off these black air conduits. This makes sure the air runs from the fans across the POWER8 heat sinks. We can see the memory DIMMs, we can see the fans here at the front where the disks are, at the back the power supply. So how do we get the PCI adapters into the machine? Well, we need to take out this back part, turn these release knobs in here, get a firm grip on this, and then we can pull out this unit on which the PCI adapters are connected. I'll turn that over. We see 2 PCI connectors on one side and the slots at the back, and 1 on the other side. To put them back in, we've got to position it in the right place and a nice firm push to snap it back in. Very quickly, once we're powered up, we get the green flashing light, a quick prod here will power up the machine. So here's my view looking down onto the top of the machine, and we'll have a look at some of the components in here. The front is on the right of the picture with the discs. You can just see the back of the discs sticking out in here. And we have the power supplies and the PCIe adapter slots. This is known as CPU1. It's actually very clearly written on the motherboard in here. And over here we have CPU2. So you can buy the machine with one socket or two sockets. If you buy the two socket version, you have to have them both filled up. I haven't seen any way to buy the machine with two sockets but only one power chip in here. Of course, we're looking at the fins on the top, the heatsink of the machine. So we can have two variations of the actual processor, the 2.3 gigahertz or the 2.1 gigahertz. The faster gigahertz only has 8 active cores per POWER8 chip. So with the 1 and 2 chips, we can have 8 or 16 cores at the faster gigahertz, or if we go to the lower gigahertz, we can have 10 or 20. Now these actually cost nearly the same price. There's about a 5% difference. So really you need to decide whether you prefer a few more gigahertz, which gives you better single thread performance, or whether you prefer a few more CPU cores, perhaps for spreading out lots of virtual machines. Now these gigahertz ratings are fairly low, but remember this is a 1U machine. There's not an awful lot of space in here for big heat sinks and big fans. So this is why I think we got fairly low numbers in here, but there is some good news. By default they're SMT8, so lots of threads are available, and it does the CPU changing of frequency. So when it's idle it clocks down to 2 gigahertz. That saves quite a lot of electricity and makes the machine run cool when it's not busy. When it's busy, which means that there is a busy process on each of the cores, then that core is switched up. It actually does overclocking to the 3 gigahertz or the 2.8 gigahertz. So this is more in the range where we normally expect our POWER8 machines between 3 and 4 gigahertz. Looking at the memory, these are DDR4 1600 megahertz. We have 16 DIMM slots in the machine, and I've highlighted them there. You could probably work that out yourself. The DIMM sizes from IBM are 4, 8, 16 or 32 gigabytes, and the 16 times 32 gigabytes is the maximum, which is half a terabyte of memory. If you've got one CPU, you need to buy 8 DIMMs. If you have the 2 CPUs in here, then it's 8, 12 or 16. Of course the 16 will give you the maximum performance, so we encourage that, although some people may want to start a bit smaller and add memory if necessary or when the workload grows. If you don't buy the memory from IBM, and I can see the temptation there, of course we have a support problem. We're not going to support non-IBM memory. So if you phone up asking for some support, then we'll say, hang on, you haven't got IBM memory in there, take out all the non-IBM components, then we'll support you. And of course if your machine won't boot, well, your problem's disappeared, isn't it? And you'll no longer get support. You've been warned. These 4 shiny heat sinks are the 4 level 4 cache controllers. They run the memory that's sitting beside them and allows very high speed memory transfers from the POWER8 processor and the caching of the memory as well. You'll see that you have 2 DIMMs there as a pair and 2 DIMMs in here as a pair. In this machine we actually have all the DIMMs filled up, which is nice. If you had only half of the DIMMs filled up, you'd have a pair, and then you'd have an empty pair, and a pair of DIMMs in here and an empty pair, and so on down the machine. We've already seen there's 4 disks in the machine in the disk bays over here. We can just see the backs of the disks in here. These are the default SATA, I believe. We can see the blue cabling in here spreading out, running through the middle of the machine to here. Now, there's a lot of different storage options, and I'm not going to go through these in any detail. I've got the simple 2 terabyte SATA drives in here, a 3.5 inch, the larger size these days. We can also have a SAS if we want it. If we have to have a SAS adapter as well, and then we could have a SAS version of the similar sorts of sizes. On the 2.5 inch we have SSDs via SATA, various sizes in here. Now I'm not very familiar with this NVMe, non-volatile memory type storage. I think of it as a solid-state device on a little card that you can plug in. The Intel guys are more familiar with this. But again, we have lots of different sizes. You see some of them are duplicated. This is because the mean time between failures of writing a lot of data to the disk are different for 2 different drives. Under here we have the 2 power supplies. We've seen that already. This little chip in here is actually the BMC service processor. It turns out to be an AMD CPU. Well, at least it's not an Intel. We can live with an AMD. Over here we have 4 little fans as a unit. I've got a picture of that on the next slide. So you can see they lift out. They sit on these 4 little pins in here, slide into this rubber connector, and they have these wound up little cables all very nicely designed. Now, if you read the announcement or even the Red Book, you'll be told that there's 4 PCI adapter slots, but one of them is a bit special. Well, one of them is up in here. We have this daughter board plugged into it, and it's running the 4-port Ethernet at the back. This just comes as part of the machine. It's not like an option or anything. It's also running this little card in here, which I think is the SATA driver, and we can see the cable running out down here to the disks. The other 3 regular adapter slots are, as you'd expect, we have space at the back. There's 2 that go underneath this part, and there's 1 that sits on top. We can just see the way that it exits the back of the machine. And we've seen how to lift this out on the video earlier. There are 14 adapters available, which is amazing, really. We have the Ethernet, the 4-port Ethernet connectors that's default in the machine. This is for the extra PCI ports, so you can select whichever is appropriate for your use. We also have the Mellanox very high-speed networks if you're doing high-performance computing with this machine, or you're doing big data and you need very fast connections, then that's available as well. Then on the storage side, if you want to do a RAID 5 for your 4 disks at the front, that makes sense. We can do that. We have a special adapter for NVMe as well. On the fiber channel, if you're doing more of a sort of data-centric databases or something, maybe you want your data out on your fiber channel SAN networks. Also, we have these advanced functions. So we have the NVIDIA Tesla K80, the GPU Accelerator. It's a graphics card that we can do a lot of maths on very quickly if your workload is appropriate. And we also have the PCIe 3 CAPI adapter. A little reminder of what it looks like around the back. We have the 3 regular PCI adapter slots. On the left we have the redundant power supplies, we saw that earlier. The 4-port Ethernet, which do your basics for you. Then we have 2 USB 3 ports. We've done an install of the operating system from a USB memory key, or perhaps you want to plug in a keyboard and then you use the VGA screen to get to the Petite boot for your initial install to get it on the network. The alternative is you use RS-232 terminal port to a dumb terminal. In the middle there is the BMC service processor port. This is an Ethernet port, although they tend to be marked up with IPMI for some reason, but it's running Ethernet into the actual port. On the operating system side, we're supporting initially the Ubuntu 14 and 16. I can't imagine why you want to use 14. And when you purchase the machine, you can buy the 3-year support available via IBM. We've also tried the Ubuntu KVM because we're not going to get Power KVM on this machine. We're moving over to the native operating system KVMs. One little warning there, you have to switch off the SMT, otherwise you can't get your virtual machines to start. So you run as the super user the ppc64_cpu --. SMT equals off command, then they'll work fine. And we've run guests of Ubuntu 16, Rails 7 and SLES 12. We expect most operating systems to run in a virtual machine like that without any problems. On the Red Hat side, we're initially supporting Rails 7.2. It does need a little fix. I think it has to get it onto the network. When we first tried it, we could install it, but we then couldn't get the network running, so it's a little driver that's needed for this particular hardware. Of course, you can run any other operating system you want in here. You can do what you like on your box. I'm pretty sure CentOS 7 that IBM now supports with that same little fix is available and should work, and anything else you want to try at your own risk. Okay, and we're done. Some final thoughts in here. Look for the YouTube page for a link to the IBM announcements. They're always tricky to find, or you can find one there for the Red Book, although you can find that yourself. Generally speaking, we're thinking excellent engineering in this product, lots of disks and adapter options, really like the 1U form factor. We can put a lot of CPUs into a 42-inch rack. One little thing to warn you about, it's not supported in an IBM T42 rack, which is very popular with the Power people. Not sure so much about the OpenPOWER guys. The problem there is that the rails on the machine are expecting the rack to have square holes and the T42 has round holes, and yes, can you believe it, it won't fit. If you've learned something, please click on the liked button below. That's the little thumbs up. We'd like to get some feedback. Thank you very much for your time.